Who here has an uptime measured in months? If you have an uptime measured in months, you may not have noticed this. But when your computer boots, maybe it goes through a series of, like BIOS or UEFI things. And one of those boot options is called PXE, or Netbooting. And in October of 2024, I was frequently reinstalling my server. And I noticed this and said, I see that in the documentation, this is often just for booting your install ISO. But can you boot a whole system off of this? And it turns out the answer is yes. So how can we boot a useful Linux system entirely off the network? We're going to want persistent storage. And we're going to want package management and system state and stuff. But first you might ask, why would I ever want to do this, right? It's kind of a strange thing to do. First, if you run a virtualized environment, right? If you're booting up, provisioning, deprovisioning a lot of VMs, then having them all boot off of some central network system rather than having to create a virtual disk for each VM might be a useful thing to do. If you're running a cluster, right? If you have physical hardware, you've got a big room full of servers and you want them all to be the same system. You want them all to share the software and the configuration. One way to guarantee that is to make sure that they are all booting from the same network image. And last of all, and the reason why I was doing this, is because it's kind of a funny thing to do. So how does it work? As I mentioned, you're going to want to boot, you're going to want to load your system, and then you're going to want to mount your system root like you would for any other system. Unlike a normal system where you're going to boot into your BIOS or UEFI, then that's going to load your bootloader from the physical disk. In this case, you are going to boot into the PXE, the pre-boot execution environment, which will find your system over the network, and then it's going to boot your kernel, and then your kernel will mount your root file system over NFS. In this case, I have another step which loads from the built-in PXE to a custom piece of software, not a custom from me, but custom open source available piece of software called iPXE, which is sort of just a better, more advanced PXE image. As I said, PXE stands for pre-boot execution environment, in the same way that acronyms that have an X as the second letter tend to take the X and not the first letter. It's the BIOS/UEFI component, which is responsible for booting the system over the network. And the way it works is when your system boots, actually before it even gets into the bootloader or the operating system, it can have this PXE, which will talk to your DHCP server, right, on your network, acquire an IP address, and ask, is this network configured with netboot, right? And that's something you can configure in your router. You can tell it, when systems boot on this network, serve them this image. And that's over a protocol called TFTP, which is the Trivial File Transfer Protocol. It's, as the name suggests, it's like FTP, but with just about everything stripped out. It can send files, it can receive files, and it can list files. And that's it. So it's very simple. It's, basically its only use is for something like this, where you're serving system configurations over the network. And finally, there's this thing called UNDI, which is the Uniform Network Driver Interface, which is the actual sort of programming interface that you program against for this pre-boot execution environment. Here's just a little diagram of the DHCP PXE flow. As I said, the PXE system is going to say to the DHCP server, which is the router in most networks, hey, do you have a netboot image? And then the DHCP server is going to either say yes or no. If it says yes, then this flow continues where the PXE client is then going to actually ask the boot service, give me the bootable image, right? And it will download that over the network. So often this is not going to be your whole Linux system because that's a pretty big, a full Linux system is a pretty big size. So often it's just basically the install CD, or it's just your kernel and init ramfs, right, in this case. So as I said, limits of PXE. You've only got one network boot, so you can't vary it based per computer what image gets booted or what rootfs gets mounted. And you can only load things over TFTP, which is a pretty simple, trivial, bad protocol if you want to do any kind of complicated file management. So that makes it great for installer images where you basically only care about receiving the image and then you're going to run it in RAM for the rest of the system runtime. But if you actually want to run your system off of this, it's not so great. And so that's where this iPXE piece of software comes in. It has various additional features. You can think of it as sort of like a bootloader or like a boot shim almost, where it's not a full system, but it basically it knows how to get the full system from somewhere else. And what this lets you do is it lets you build in an embedded script to the boot image. So for example, you can say, when a computer boots this image, I want to ask some other server, hey, here's my MAC address, or here's some identifier for this particular system, for the hardware that it has. What image should I boot? And you can do this over HTTP, iSCSI, NFS, right? All the sorts of normal protocols that you might actually want to use for a more complicated, longer-term system, boot. And the problem with that is that it's almost never built into your system motherboard, right? The PXE is part of your BIOS or your UEFI environment. So that's built into your motherboard ROM or your network card ROM. So you don't have this iPXE, you just have whatever the manufacturer gave you. And so the solution for that is actually the image that your default PXE serves will be this iPXE piece of software, right? It's like a trampoline, if you've heard that term used in a software context. What does the I in iPXE stand for? It doesn't. This is from the official wiki, so in case you were curious. So your boot sequence. First, you are going to load your kernel and your init ramfs. Your kernel is going to execute the init program on your in your init ramfs in order to mount your root file system and whatever file systems are on your FS tab. And so if you're booting over the network, right, if you want your root to be a network file system rather than a physical drive, you've kind of got two options for that. You could build the NFS module into your kernel, in which case you can just tell the kernel in your normal kernel command line, hey, your root file system is this NFS mount. Problem being that a lot of distro kernels don't have this functionality by default. So you would have to build your own kernel, which can be kind of a hassle, especially getting that integrated with your distro package manager may not be easy. So you can also, again, have your system, your iPXE, load an init ramfs. So you could just build your initial RAM file system with the module in it for network booting, or network file systems. At this point, we've already booted. So once you can boot your system, right? But there's still sort of this question of how do we make it useful? How do we get this configured? We're probably going to want some software on our system, right? We don't just want a kernel. That's not very good. So we've got some options. First, we could have a single immutable image that every system boots from read-only. We could have each system that's booting off of this network server have its own root, right? So we've got one big NFS share, and then maybe you've got a /root/ laptop /root/ server1. And then each system looks up the correct root file system and mounts it. And then there's GNU Guix, which is a immutable Linux or a declarative Linux distro, sort of like Nix. And it's got some interesting features that can enable a sort of hybrid between these two, the immutable image and the individual root options. So our immutable images, again, it's good for clusters, right? If you're running, say, a supercomputer cluster, and you just want everything to boot up and run, Boink, or whatever other distributed computing software you're running. They've all got the same configuration because they're all just booting off of one read-only file system. It's great. If you need, maybe if you need to mount additional software on certain systems, you could use an overlay FS sort of deal, or mount mutable temporary data file systems over that. And again, it's useful if we want to guarantee that all of our nodes are the same. But a lot of computing environments don't want all of their nodes to be the same. Right? If you're running, say, 10 different services on various machines, they probably all have different configurations, different sets of software installed. So you might want to have all your systems have individual roots. And again, as I said, this is also good for virtualization, right? Normally with a virtualization sort of setup, you have disk images where every individual VM is booting off of a disk image on a hard drive, on the host. But first of all, maybe you want your VMs to be easily readable from the host system. Second of all, maybe you want to migrate VMs from host to host. You might want to boot your VMs over the network and have them mount individual roots for each VM. And again, they're going to mount different subdirectories of the overall network share as root. They'll mount it read-write. And if we want, we could even have different distros or even different operating systems per machine. And that's easy. And the downside with that is that maybe you run everything off of a base, say, Rocky OS Rocky OS, Rocky Linux image, then all of your root file systems are duplicating this base Rocky Linux image, right? If every virtual machine has its own root, then obviously the root will be duplicated. And maybe if you've got a minimal, I guess if you're running like Alpine, that's a minimal amount of storage, but if you're running something heavier as your base image, then maybe that can add up. For context, I gave this presentation originally at my university lug. And one of the people at my university lug was a big fan of this Linux distro called GNU Guix. If you've heard of NixOS, it's very similar to NixOS in that you just have one central configuration file which builds the system based off of that. What Guix has as a feature that NixOS doesn't, though, is the ability to run sort of the central package manager or configuration daemon as a network service. So with this Guix system, you can actually have one central host that runs the package manager as a network service, and then all of your client or netbooting machines will, whenever they want to install a package or change the configuration, just talk to that central server and say, hey, can you install the package? Which it then installs, again, on that rootfs that these systems all share over the network. And then the package, each system can have its own view of the configuration and its own ask for different packages. But the actual storage, the actual Nix store or Guix store is shared. So we can still have our individual systems and runtime package management and all these things that you expect of like a traditional Linux install. Without this problem of duplicating all of our files everywhere. And as far as I'm aware, this is still true, that NixOS does not have this feature, at least not in the stable version of its system. It's still considered very experimental, whereas the Guix version is considered usable. I think that's the talk.
So, I got a question with that. iPXE, does that iPXE image need to have like drivers for your specific hardware, like the network drivers? How do you get past that?
So your network card has this firmware built into it called UNDI, the Universal Network Driver Interface.
So if your system supports PXE, is that kind of guaranteed?
Yes. It's guaranteed that you've got at least this UNDI interface, which is enough that iPXE can then boot whatever operating system you want over the network.
Okay, cool. Sorry, can you talk about your experience? What are you actually booting from using the XE?
So, sort of embarrassing, I actually kind of gave up on this project. So it turns out that Guix is very good at doing sort of this distributed stuff, doing this HPC cluster sort of stuff. And then when you want to actually like run normal software on it, there's just like not packages or pre-built services for it because there's like 3 people who use Guix. So I kind of ended up choosing the convenience of having a regular Linux distro on my server. I also don't have a massive cluster of like an entire room full of server racks, so the use case just wasn't there for me. Sorry to disappoint you all.
So have you actually booted?
Yes, I was running for a very short period of time. I was booting Guix over the network from.
So do you happen to be familiar with Werewolf?
I am familiar,
Okay.
vaguely.
Yeah, Werewolf uses basically this as an HPC cluster provisioner.
Right. My understanding is that Werewolf is more of a sort of provisioner rather than sort of a...
Well, that's what you're doing here.
It is, but how do I put this? I could have the wrong impression. The impression that I got was that Werewolf is more booting and then leaving an image in RAM rather than booting and then having this long-term root on a...
You can do like...
But I could be wrong.
It's stateless, but you can also do stateful as well, where you can boot it, you can install it to a disk.
Also, do you happen to be familiar with like the old Sun workstations? So PXE was actually the original model for workstations back when storage was really expensive.
Yes.
So it is kind of funny to see this, I don't know, not revived, but reinvented.
Kind of the inverse now. It's like very inspired and hard so cheap.
Yeah.
I don't know, is it revived? It seems like I've never
Well,
used it myself, but it's kind of
Well, not
right?
not revived, but reattempted. I don't know. It's
I mean, it's always been available to anybody
Right,
that needed it for the most part.
yeah. No, well, I guess it's fun to see people rediscovering it.
Yeah.
I guess.
How did you come across the network booting? Is it something you always knew about?
So I said at the start of the presentation, I had been reinstalling my system, my server, quite a lot because I hadn't quite decided what distro I wanted to run, or how I wanted everything configured. And there's just like this, like the boot prompt when your system boots up, and it says, searching for hard drive, searching for, and one of the things that always shows up is like searching for PXE, and I'm like, hey, netboot is a thing, but like all of the documentation always says like, netboot, here's like how you can boot the install image. Here's how you can boot like the live USB from the network. And I was kind of curious, can you actually like boot a full system off of this?
Actually, on a desktop, you always find nowadays it's default fast startup, and the difference in the BIOS between normal startup and fast startup is basically disabling PXE. If you disable PXE, that option doesn't change anything. So that's actually on desktop, I do suggest to disable it if you don't use it and leave the normal BIOS. But and on server, PXE is the difference between booting in 5 minutes, talking about BIOS, and even longer. Like some network cards take forever to time out PXE.
That's how I first noticed it, is the system would stop for like 10 seconds every time it was PXE.
Because on server it's not once, it's a timeout for every NIC. And if you have a normal server with 12 network interface, it will be a lot.
Right. Well, because it needs to reach out to the DHCP server and then actually get a response back saying, hey, do you have anything for me to boot?
But a word of caution, I played a little bit with PXE because I feel it's a little bit dying actually, but it used to be the right way to do stuff with hyper-converged storage network. You would have in your rack one SAN. You connected every server by not normal network, a lot of time is a fiber channel.
Right.
So you're doing a separate network for storage because...
That's sort of the fourth reason why I gave up on this, by the way, is that my network was only 1 gigabit.
Yeah, I was about to say that consider latency because when this was iPad, gigabit Ethernet latency is similar to hard drives. Sometimes an hard drive is a little higher in bandwidth, but gigabit Ethernet is a little higher better in latency. But if you consider SSD, not even 10 gigabits reach it. Like with fiber channel, I have some old fiber channel cards, Hopefully nobody in the company is checking for that. They are, the old one are 20 gigabits a second. The new one I got, they were about to throw them, were 40 gigabits. And I think nowadays they are doing 80. And
Still slower than a
still is
SSD.
nowhere near close NVMe. So, but I mean, if you're just, if you're
It depends on if your storage
if you're doing your storage layout
limited or
right,
compute limited.
I mean, you could do root over network and then mount var locally. I mean,
Do you do any shenanigans with waking on LAN?
No, I haven't done any shenanigans with waking on LAN. I have no idea how that would work with this, but it seems like a
Is it possible?
bad idea.
Like, could you remotely wake up the computer and then get us around all this?
Probably. All right, well,
Thank you.
thank you all.